Welcome to Elektor Engineering Insights, the show that puts your engineering challenges to the industry's experts. I'm your host, Stuart Cording, the electronics reporter. The past years have been challenging for the electronics industry, with chip shortages holding back the delivery of, well, just about everything. So where do you get parts at such times? Well, not a day goes by without an email in my inbox from someone offering a list of parts. So do I buy those? Do I look on eBay? Or are there safer alternatives when distributors can't deliver? And when we think about the semiconductor industry, we're often thinking about silicon. But what impact do these companies have on packaging? Can you be a success in power devices like MOSFETs without an eye on packaging trends? So to find out more, my panel of experts for this episode are Krishna, Ganason and Max Gates of Fusion Worldwide and Chris Boyce of Nexperia. Welcome to the show, everyone. I'm going to start with Krishna and Max. Hi, welcome to the show.
Hi, thank you for having us.
You're welcome.
Stuart, thanks for having me.
So Krishna, let's start with you. Maybe you can tell us a little bit about yourself and your role at Fusion.
Yes, I'm with the Fusion Worldwide. I'm the director of the global engineering for Fusion Worldwide, where I lead the engineering team. My main task is to drive changes and provide technical support for our customers. So my experience includes semiconductor manufacturing operations with one of the largest OCM in the US for 15 years prior of joining Fusion.
Fantastic. And Max, what about yourself? What keeps you busy?
Yeah, so I'm a customer quality engineer here at Fusion. I also came from one of the largest OCMs. I've got about 3 years of experience with failure analysis engineering, as well as customer quality engineering. So I've got some semiconductor experience in my belt.
Great. That's fantastic. Super. Well, stay on the line. We'll be back with you shortly to find out a little bit more detail. I'm just going to move over to our other guest now for today, Chris. Hi there, Chris.
Hi, Joe.
Good to see you. So tell us a little bit about your role at Nexperia.
So I am responsible for the marketing of our MOSFET portfolio and also the latest, greatest GaN devices. Been with the company about nearly 12 years. Prior to that, I've worked at a bunch of companies who would have been Nexperia customers. So in some senses, I guess, similar to some of your audience.
Fantastic. Well, thanks very much for joining us. And as I said, keep on the line and we'll be back to explore more very shortly.
Look forward to it.
Just got to find my mouse and there we go. Super. See you later. So visiting trade fairs and chatting with engineers allows me to gauge what's happening in the electronics and semiconductor industry. However, this show is for you engineers out there struggling with your designs. So regardless of where you're watching, post your questions and comments during the show using the chat function on YouTube and LinkedIn, or send us a tweet on Twitter using hashtag ElektorEI. And we'll do our best to get answers or guide you to some resources that might help. So let's get back to Krishna and Max from Fusion. Welcome back.
Thank you.
Thank you.
So chip shortages were the number one topic of the conversation during the last couple of years, primarily caused by the pandemic. And Fusion is a company that solves supply chain issues for electronic components. I don't know, Krishna, maybe you want to start. Could you sort of give us a brief overview of how Fusion helps with these supply chain issues?
Yeah, absolutely. So if you see, right, Fusion Worldwide is one of the largest independent distributor of electrical components. We use our trusted supplier network to help resolve supply chain imbalance and absolutely keep our customers' business on track, right? And this particularly significant role we played during the last couple of years of the pandemic. We saw fluctuating pricing and the long lead time. So Fusion is here to help customer react to changes quickly. So I can pick a very quick question, a very quick example. Recently, there's a fire in one of the manufacturers in China, Fusion was the first one to react in the industry to help our customers source for important parts so they can keep on going building parts and be in the business constantly. So that's how we actually being a significant role in these times.
Yeah. Now, as I said in the beginning, I'm sure you get it too. I think everybody in the electronics industry gets some random email offerings, a list of parts and prices. And I think, when I know lots of companies who've struggled to source critical components for their applications. And obviously there's a temptation there to go for it, but you have no idea what is behind those organizations. But you've actually got a video which was put together with your CEO, Paul Romano, and I'd just like to show everybody a section of that video so as everyone gets a feel of what goes on at Fusion to make sure this whole thing happens.
Absolutely.
On the inspection floor and in our screening and analysis labs, we use 4 levels of magnification, including high-end microscopes up to 2000x. We use chemical decapsulation to expose and read the die. We use X-ray to look at lead frame, die, and bond wires. We use XRF to ensure each part meets RoHS standards. We use heated chemical tests that go beyond simple acetone and scrape. And we have in-house solderability testing. We access tools like the IHS and ERAI databases. They're searched with each receipt and allow us to view data sheets, PCNs, and end-of-life notices, as well as counterfeit parts and the vendors who ship them.
So I think that gives us, a really good overview of what goes on in your facilities. And electronics is a very broad remit, electronic components. Are you just helping customers with sourcing semiconductors?
So as one of the world's largest independent distributor, Fusion Worldwide established, a large global network of suppliers, right? So we can find the hardest to find electrical components and products to get what the customer need and when they need it, when others can. So that includes IC, semiconductors, diodes, transistors, passive, connectors, and magnetics, and etc. So anything in electrical components, so Fusion is there to help our customers.
Yeah, really anything that can reliably go through our QC process, right? Really, Fusion, I think, is in the business of risk mitigation. We're really just trying to mitigate that risk to our customers in terms of what they're getting. The open market is a beast that needs to be tamed in and of itself, and I think Fusion, and any other broker really, but I think Fusion has that reliable QC process to really help with that.
That brings me on to that challenge of fake parts. I attended a presentation a year or two ago where there was a university professor who'd spent some time analysing parts, and it's very difficult, isn't it? Just looking at the package of a power device, an IGBT or a MOSFET, and even a microcontroller, and telling whether it's real or not. They look from the outside to be completely genuine parts. So where are your parts that you're supplying actually coming from?
So for Fusion, that's a great question. So that is one of our challenges, is the fake parts. So Fusion established a robust quality-oriented process to manage our vendors. So quality for Fusion really starts on our vendor selection. They are all cherry-picked while we have a vast vendor, but we are very, very particular in terms of qualifying our vendors. So they go through a qualification process and they are rated real time for each of the POs that we are getting from them. We look and evaluate for vendors with specific values. We go beyond at what are the value added that they bring in. Are they working on a specific line? How do they have a network with an authorized disti? If they have access, we want to understand, are they a big consumer for a specific product line, like from Texas Instruments, Xilinx, or Intel? So those are the elements that we assess very carefully when we select our vendors. And like I said, the rating is being rated on real time and is visible globally to all our QCs, buyers, and as well as sellers. So they get to see our vendors rating, and we go by class authorized, right? So we start with an OEM, CM, access, and the distributor. There is a defined buying process that specifies the hierarchy of where we purchase the parts. Of course, we want to go to the authorized disti first, and then we go with our qualified vendors. But most importantly, where we source the part is transparent to our customers. So the customers knows the source type, and we mitigate the risk with our QC process according to our source type.
Now, in my experience as well, I've seen some of our microcontrollers from a previous employer turn up on the grey market. Someone was looking for some, we didn't have any, they asked us first, and then sometime later they came back and said, oh, we found these parts, can you tell us if they're genuine or not? And we said, well, they are, but they're pre-programmed and you can't reprogram them. So do you ever source parts as well from big manufacturers like, for example, a Bosch or a Siemens, when they've got reels left over that they just don't think they're going to use anymore? Does stuff come in from that path as well?
So yeah, without picking any of the ODMs or OEMs, yes, we work very closely with them, right? Some of the right now automotive is such a hot market, so we always try to go by authorized disti and then the ODMs, and we work with some of the largest ODM. They are not only supply access to us, but we also sell to them. They wanted different types of other components for them to build the board. But again, like I say, we always fall back to, are they a big consumer of that certain parts that they have the access, right? Regardless, what is our source type? They always go through our rigorous QC process, which includes thousands of QC inspection from the packaging, labeling, the parts, and as well as the lab testing, acetone tests, high chemical tests on the parts, X-ray tests, and exposing the die, making sure the die is, the die code is consistent to a golden step, and as well as the electrical testing. So I think recently Fusion has acquired ProSemi, one of the largest test house in Singapore, that gave us significant electrical test capability. And I think electrical test is very, very important as the other steps, the last step, ensuring the parts are good. I can give you an example. Recently, we have added an extensive MOSFET testing. As you know, MOSFET consists of gate, drain, and source. So ProSemi offers a very high-end MOSFET testing, which include IGSS, IDSS, breakdown voltage, VDS, and recently we also added RDS on test because one of our largest automotive customers asked for an RDS on test. RDS is in a very complex test where you have to turn on a MOSFET with a high current and measure the resistance between the drain and source. So those are the complexity electrical testing that we offer with the gain of a ProSemi.
Yeah, and also, we source a whole bunch of different parts, right? All these passives, all these MOSFETs, for example, they all behave the same way, no matter what manufacturer they're from. The data sheet will be different. They'll have different characteristics, for example. But a MOSFET from TI is going to be the same as a MOSFET from any other manufacturer, for example. We know how those behave, and with any of the more proprietary parts like CPUs, GPUs, where for more functional testing, we might need the manufacturer source code, which we are not going to have. There's always certain tests we can do, like unpowered pin-to-pin curve traces, where we can actually look at the pins themselves and see, okay, how does that match with a golden sample whenever we receive parts? So there's really always stuff we can do, no matter really what the part is.
Yeah. Now, obviously you've explained that you build up a huge range of trusted vendors to as far as possible ensure that the quality of the material coming into you. Are you in a position to sort of trust some vendors so far that when they send you a reel of product or a tray of product, you can just say, yes, this is okay? Or does everything that comes into your warehouses and into your storage have some samples tested to make sure that it's really what it says it is?
Max, do you want to take that?
Yeah, so I mean, really everything has to go through our QC process. Like Krishna was mentioning, we do have a proprietary software that does rate vendors based off of, past history with them, along with all these other metrics that Krishna was mentioning. But everything has to go in. We really are never going to have enough trust to any vendor to where we can just say, oh yeah, sure, we can, bypass our QC process, because, even if we've worked with them for the last 10, 20, 50 years, however long, doesn't really matter. Everything needs to go in, and everything will be a suspect counterfeit until we can prove that, hey, yeah, this is probably good material.
Now, I've come more from the digital and embedded microcontroller space, and I know as we develop those chips, we develop a series of like patterns that get downloaded into test equipment in order that something complex like a microcontroller to be tested, and that's a different level of testing to something like a MOSFET, a 3-pin, 4-pin device. Right. Do you also have access to that test equipment and all those proprietary test programs, or do you have to prepare some of those things yourself?
Yeah, so Fusion already think ahead of that, right? Fusion has we actually built a Fusion's engineering team recently. We designed engineers across some of the largest OCM. We have 7 electrical engineers across USA, Europe, and Asia, representing significant semiconductor experience globally. Fusion test engineer, so she brings in extensive experience. She works with some of the largest OCMs across ADI, Skyworks, and TDK for the last 20 years. So she enables Fusion to provide significant engineering support in terms of redesign our test capability, and she designs our test board and test features as well. Of course, we are not going to do that extensive testing as the manufacturers, but with our in-house capability that she brings in, she really helping us to develop the tests in-house. So for instance, right now, Fusion is really careful analyzing how the world is going to be in the next 5 to 10 years. Automotive, IoT, robotics are some of the futures, right? So we're really intelligently investing in preparing to support those industry. And electrical test is so important, especially for our automotive customers. So we are expanding test capability in ProSemi, and we are also adding more test engineers around it, so we could build more test capability in-house to support those tough customers industry.
Super. So one of the things, maybe if you could take us a little bit through the process in a bit more detail. What sort of tests do you start doing when you get a batch of products, and in what sort of order do the tests then go from optical inspection through to maybe more sort of a destructive testing processes?
Okay. Yeah. So in Fusion, we have a very detailed 5 steps of inspection process. We really starts from the receiver 1. They inspect the outer package, labeling. The packaging has to be as per the MSL level by the manufacturer. So they really compare to the data sheets all the informations, the SPQ, standard packaging quantity. And then the next one is this receiver 2. They pretty much do the same thing, all the inspection on the labeling, because label is really the first steps that is so important, because for any kind of genuine parts, it really starts from the labeling. Any misspelling, different types of label, factory seal, non-factory seal. And as well as they also scan in label on the barcode label information. They actually check against the human readable, is it everything looks good? Because sometimes when the parts is not genuine, they could make all these small and silly mistakes. So that's what they're looking for. The third step is the QC. QC really access not only the packaging as well as the parts itself. They access the parts. They look for the texture of the body of the mold compound, the leads. Is there any prior use on the leads? The consistency of the date code. How many date code has been in one reel? Is this within the manufacturer's data sheet's requirements? And they also, like what in the video Paul was mentioning about IHS and as well as Silicon Expert website. So the QC access to all these websites, making sure that the vendors is qualified, the parts are qualified, and there is no any counterfeit risk on this parts and as well as the vendors. And then it goes for lab testing, acetone test, high chemical testing, making sure there's no black topping, X-ray, making sure the lead frame and wire bonding is consistent. And then the last step is the electrical testing that we really offer, as what Max was mentioning. We start from the curve tracing. We check for the NP junction of the diodes for some of the critical functions, VCC, VARC, V-in pins. And then we go for extensive functional testing for MOSFET, for ICs. So depending to really what other customer is asking for, we are building the electrical tests around them. We also expanding into temperature testing and as well as the other complex testing.
There's a lot of stuff that can be checked throughout the QC process, right? And all it takes is for one little slip up from a vendor to, put a red flag on it. And there's so many things that they can slip up on that, our process is just so intensive that really any sort of slip up, we'll catch it, and any sort of red flag will be looked into, and
Super. So we're rapidly running along in time, and it's fascinating to understand as someone who's been in the industry and seen the semiconductors manufactured to see how this process works. And one sort of last question before we have to move on to our next guest was to understand how the whole process works for a customer. So if I visit your website, and I think some of our viewers will probably be doing that right now, you're not set up like a traditional component distributor with a list of parts and prices and a little shopping basket. So if someone is having difficulties with sourcing products and passives and silicon devices, how do they engage with you? What's that process look like?
Yeah, so it's so easy. We have a user-friendly website. You just go to www.fusionww.com. It's a user-friendly website that you can request for code. List of contacts is there, services that we provided, latest certifications. So we have a range of certifications for this company, so you can access to that. There's also quality process overview, location we operate globally, and products that we support, and mainly and many others, right? So you can go in and there. So if you need any parts, or you have to reach out to some of the our contacts, and that website is your go-to place, and we will get back to you within hours.
Yeah, right. We can also help with sourcing alternative products as well. Sometimes parts we can't source specific part numbers, but maybe customer doesn't care about the package type, or pins 6 and 7 might be.
Yeah, that's a good point. Yeah.
There's always some sort of small variations of some parameters which maybe aren't so important. So that's fantastic. Well, thank you ever so much for those insights from Fusion. Stay on the line, because we're going to be coming back to you at the end of the show to answer a couple of questions. I just quickly look at who's online at the minute. There's a little greeting here from Astrid van Breda. She says hi to the Fusion team. Udo and Shenya and Patrick. So plenty of people on there as well. I've got a question from Dom, which I'll look at later on, and we'll see if we can get an answer for him. So hang on there, Dom. We'll be with you shortly. So thanks very much, Krishna and Max, and we'll see you in a bit.
Thank you.
Okay, now it's giveaway time. Firstly, congratulations to last episode's winner, Roman. Your tablet Mixig oscilloscope is on its way. To extend our thanks to you as loyal Engineering Insights viewers, this episode I have a Microbit Tinker Kit. The Microbit is a great development board aimed at kids, introducing them to the world of computers and programming. It's included in this Tinker Kit, allowing you to extend its functionality with an OLED display. And to make sure you know precisely what we're talking about here, I'm just going to pull up the picture here on the display for you. There we go. So that's the Tinker Kit and everything inside. An OLED display, it's got a servo in there, a range of sensors and some LEDs as well, to name a few of the things that are included. To make it all easier to build, a breakout board is also included, so no soldering required. For your chance to win, simply visit the link shown below and enter the keyword shortage, that's the keyword shortage, with your entry. And good luck! So, joining me now is Chris. Hi, Chris, back with us.
Hello again.
Just going to tidy up the display there so as we can actually see you instead of not just the Microbit. So thanks for joining us. Really appreciate it, taking the time out from your busy day at Nexperia. And when we started setting up the show, one of the things that occurred to me is that I think electronics engineers, and I blame myself here a little bit as well, we see semiconductor vendors as innovating in silicon. And I don't know, somewhere along the line, you go to some ethereal supplier and choose a package. So how deeply does the semiconductor industry get into package development for their chips?
It's an interesting question. Obviously, the performance of the device is a combination of the silicon and the package. But particularly for power electronics, which is the area that I'm most involved with, quite often it's a thermal challenge around the performance of the device. You know, we're squeezing these devices into smaller and smaller spaces, you know, often without airflow. So if you take the joint of a robot, for example, you've got 6 MOSFETs housed in a very constrained space, having to manage quite a lot of power in terms of moving that robot around, and so it becomes really a thermal challenge. And there are 2 ways to address that. You can create less heat in the first place, and you do that typically by using a more efficient MOSFET, lower RDS on, or one with better switching characteristics, so that the device is more efficient and you waste less energy, and that energy normally turns into heat. Or you find innovative ways to get the heat that is generated out of the package. And that's really where the packaging element comes in, is how can I get the heat out and away from the silicon so that it can operate safely.
So one of the topic of conversation for us today is the LFPAK, which is a particular type of package. It's sort of, if you want, the great grandchild of the TO220, which was sort of a mainstay of power devices for many years when we wanted leaded components. And you've actually got a little video here. I'd like to show a part of it to give some sort of background on the LFPAK, where it's come from, and what it's capable of.
Please. Far more interesting than me.
I love that. I can hear the sound of that sort of a motorized skateboard. I can feel it. I know exactly the whining noise it's going to make. And although there's only a sort of a small section of the video there, looking at the whole thing, which I think is available online, it makes possible higher levels of integration in power applications, as you said. In automotive, there's 20 of these types of packages integrated into the vehicle for everything from steering and seats and mirrors to braking. And of course, it makes things like micro-mobility, like e-bikes and e-scooters, possible at all, because without it, you just won't get the things that small. So it was the package is, as we saw there, is already surprisingly 20 years on the market. Back in 2002, it was launched by Nexperia. So what improvements, sort of electrically and mechanically, were sort of achieved at that point in time to make this type of package possible at all?
Yeah, a couple of really important innovations. Firstly, it was the first power package on the market that really focused on what we call copper clip packaging. So if you look, quite often you see assembly plants, and you'll see a piece of silicon, and you'll see a wire bonding machine stitching lots of connections to the outside pins. And that's the way that power packages used to be. That's indeed what a TO220 consists of. It's got a big slab of metal at the bottom, and then you put the die on top, and then you stitch from the surface of the silicon to the external legs. What LFPAK introduced was a new construction that was essentially the drain tab, a piece of copper. I'll put my hands up here so people can see. And then there's a layer of solder, and the silicon is then connected to that. And then there's another layer of solder, and then there's a copper clip that comes down on top. So essentially, you've got a sandwich, the silicon sandwich between two pieces of copper. And these are vertical devices, so the current is flowing through from the top to the bottom for the device. And if you think about it, both electrically and thermally, it's pretty difficult to envisage a construction that could be more efficient than for getting the heat out and for keeping stray inductances down and the RDS on down than that construction. Today, there's lots of different packages that employ that type of technology. 20 years ago, nobody did it that way. And that was the innovation that Nexperia brought to the market with the LFPAK. It also has these kind of gull wing leads that kind of stick out. And again, these are power packages that they heat up, they cool down, they heat up, they cool down. So you've got your car that's maybe down below freezing overnight, and then you get in and you turn it on, and you're running at more than 100 degrees pretty quickly.
Yeah.
Mechanically, you've got some different thermal coefficient of expansion between the PCB and the package. And if you don't take care, then in that thermal cycling, you end up with cracks and ways for contaminants to get inside the package. You end up with strained solder joints. These external leads, the surface mount device, but these external leads act like little shock absorbers, if you like, and they manage that difference of expansion. And you end up with a very reliable package. Again, at the time, that was we used to show that in PowerPoint. Now, with a huge number of these devices out in the marketplace in some very tough conditions, strapped to the side of engine blocks of internal combustion engine cars, and they survive. We've got some great history to put some evidence against just the theory.
So with the LFPAK, is that package today only used by sort of MOSFET or transistor type die, or is it also used in other types of product?
It's principally MOSFETs, power MOSFETs, and now we have not just one package. We started out with a 5x6 sort of power SO8 footprint, but we've gone down into 33s, 3 millimeters by 3 millimeters. We've gone up to LFPAK 88. By the name would suggest, and mostly we do have some polar transistors in that package as well. Again, at the higher power end of the thing, because it's in these power applications where it really comes into its own.
Yeah. Now, obviously, we've talked a lot about power in the show in the past, and you know we're seeing these power applications. They need to get smaller. We need a higher power density. We're also moving, as you mentioned earlier, to GaN as a technology, which is helping that trend by making the magnetics smaller. But when it comes to something like packaging, there's a lot that goes on in the background, isn't there? There's first the manufacturability. That maybe the tape and reel size is different to what we're used to, and there's the optical inspection for checking that that's soldered on properly. So when you invent a new package like this, how difficult is it to encourage customers to go with it, bearing in mind at that moment in time it's a single source component?
Yeah, fantastic question. And as you can imagine, over the last couple of years, with all of the shortages that there have been in the marketplace, single source components are a concern, and there's everybody's trying to find ways to give themselves some flexibility in the supply chain. One of the things that we did initially with the 5x6 was that we made it footprint compatible with other Power SO8 packages, so other devices that weren't clip bonded, but they were wire bonded inside. But we standardized on the footprint, so at least you had the option to switch around from a packaging a package compatibility viewpoint. I have to take issue a little bit with Max earlier on when he was saying, all MOSFETs are all the same. Yes, they've got a gate, a drain, and a source, but there's huge differences in specification when you look at the individual parameters behind that. But certainly mechanically, if you can get it on the same footprint, that's good. And we actually went out and introduced a universal footprint, as we call it. So that was something that we would put out into the public domain, where we had done some testing done by an independent consultant that basically confirmed that if you laid out using this universal footprint, you could with impunity swap from different packages from different manufacturers. So that kind of helped that. But looking at it a little bit more philosophically, a question about, what do you do about, if you come up with an innovation, and maybe some of our listeners here or viewers here are have exactly the same challenge, right? On the one hand, you want to provide something that people are familiar with and feel confident with, and on the other hand, you want to be innovative. You want to be differentiate. You want to differentiate against your competitors, and that's the innovator's dilemma, if you like. Because what you're really telling me is, if you're only going to use a second source, if you'll only accept a second source product, what you're really telling me is you don't want me to produce the best product that I can.
Yeah,
okay?
Exactly.
And then I'm starting to get challenged a little bit as to what there must be some people out there who, and it depends on the step of the step of up in performance and the innovation. But if you have something that is really differentiated, that really allows your customer to build a better product, why would I keep that under my hat? Why wouldn't I put that out into the market and encourage people to use it? And not everybody will on day one, and you'll find that but some people will take the risk because they see the value that in their product that they can do. And then you get and then we have engineers arguing with purchasing people about that I'd really like to use this component, and the purchasing guys no, they're not, it's not on the OVL, or there's that whole for good reason. There's all sorts of challenges around that. But if we didn't do that, we'd never move forward, because we'd all be just copying what is already available. And we took the decision 20 years ago we thought that copper clip technology was sufficiently higher performance than the wire bonded equivalents. And of course, there were lots of naysayers, internally as externally. But here we are, nearly 10 billion units later, the choice.
So the obviously one of the other parts of this process of accepting a new package is things like manufacturability and getting customers to sort of adopt a new package. What goes on after the point that the engineers, the design team, have said yes, we're willing to innovate with this package? What needs to happen afterwards? And in terms of applications, I'm guessing that things like consumer applications tend to be early adopters of this, but maybe the more conservative, maybe sort of functionally safe markets like automotive then come to this later.
Yeah, I think that's true. I think, and it makes sense, right? I mean, if you've got, if what it's going into is a small device that is not used in a kind of a critical application, people are perhaps prepared to take more of a risk in the first instance. Whereas if you're controlling the automatic braking system of a car on a public road, you're going to be a lot more conservative about how you adopt these things. It got used in PCs first of all, as in sort of DC type environment inside PCs and notebooks. It then found its way into all sorts of battery controlled appliances. And then after a while into some early automotive applications, and now a very large proportion of our sales of LFPAK are into an automotive environment. So yeah, it takes time. In terms of that process, that kind of diffusion of innovation, as it's called, it's important as well that you don't just provide a fantastic innovation as a product. You have to support it as well, and that, like the idea of the universal footprint, in terms of making sure that all of the evidence that it really performs as it should do, and it justifies that risk taking of going into a new area by providing good reliability data, good support materials, good FAE support in terms of getting the thing designed in. All of that helps to make people feel, okay, it's here to stay. The company's making an investment in this. It's not going to be here today, gone tomorrow. And what you find is actually where innovations are accepted, then the purchasing guys stop saying to their own engineers, you mustn't use it. They start asking competitors, can you make one of these, please? And now what you find is there are LFPAKs available from a number of people, not just from Nexperia. And I guess that's as they say, imitation is the sincerest form of flattery. So it's LFPAK in particular has gone past that point.
Fantastic. So we've got time just for one more question in our one-to-one session here. And I think you come straight to the point I wanted to address next, was obviously standardization. You've come up with a package and defined it all, but then in order to bring that to market and make sure everything that stands behind the process of turning a prototype into something we can manufacture and sell, we need to sort of standardize not only the package, but also the packaging that it's delivered in, the tape and reel, pick and place machines need to be able to work with it. There's optical inspection, solderability, and all of these things. And typically that will get standardized in what's called a JDEC standard. Can you tell us a bit more about how that process of standardizing to JDEC comes about?
Yeah, it's a very good point. I mean, there are these standards organizations that help take some of the risk out of the equation for customers that are going into these areas. So we very early registered the package details with JDEC and also their Japanese equivalent GDEC, and that does help to present some insurance, if you like, again, that it's here to stay. It's not just we'll build a few of these and see if they take off and then get out of it. Because for the early years we didn't sell so many. It takes a while for the message to get out there, for people to try their own tests, to feel comfortable with the reliability, with third parties to start to put the similar packages on their roadmaps, and applying for a JDEC standard and getting the the endorsement, if you like, of that of those types of organisations is a very important part of the process.
Great. Well, thanks ever so much for providing that overview of packaging. As I said at the beginning, I don't think we take enough time to understand that the packaging is such an important part of the component. You know, so much time and energy is invested in FinFETs and 2 nanometer, and it's all silicon. And obviously, without a package to put it in, you know, we can't. Not many of us can't do very much with it. We have enough trouble soldering the parts we have. So thanks ever so much for that. I'm just going to bring in our Fusion team here as well. There's Max and Krishna back with us again. And we've actually had some questions come in. So if you do have any questions for our experts today, we're available here through the chat function on YouTube. Also on LinkedIn, you can send us messages. And if you want to, you can send us a tweet with the hashtag Elektor EI. And I'm going to go straight now to a question for the Fusion team. This is from Dom. He says, do your customers hold you accountable or the original manufacturer vendor if they get a faulty component? And there's a bit of a clarification as well. I think, so are those customers coming to you first and saying, you know, I'm seeing an unexpected level of failure in these parts? Or, you know, do they go to the original supplier in that case?
Right. So that's a great question, right? So all the parts that Fusion sell, we stand behind it, you know, in terms of the quality as well as the functionality. So we actually brought in Max. He's one of the, you know, he came from extensive experience of failure analysis, and he takes care of all the customers' quality issues globally. And we do have an in-house website that customers could come back to us with any faulty parts in terms of mechanical or electrical failures, right? We also have an extensive failure analysis lab in the US and as well as in Singapore to support failure analysis even before we could know what's going on the parts. So really, Max and his team is designed to support customers at the first level of failure analysis and just understanding and diagnosing what are the issues that the customers is saying. And obviously, some of the isolations requires on the die level, right? Some of the electrical functional failures and really looking at the delayering of the die. And those complexity, we usually try to reach out to the manufacturers. So because we do need the die schematic in terms of isolate the electrical failure on the die itself, or even in the packaging level, right? Sometimes it passes time 0, but it fails in the field over time. So those kind of extensive complex FA, we reach out to the manufacturers. We try our best to help our customers to reach out to customers. As a distributor, as a customers, they have more way to go back to the manufacturers as we as a distributor. But again, at the end, we stand by for all our parts that we ship out. That's really the main reason, like myself and my engineers and Max are here to help customers resolve the issues. Yes.
Yep. Where we really excel is through non-destructive tests as well. So, you know, you have non-destructive and destructive whenever you get a customer return. And like Krishna was mentioning, you know, you need for a lot of that high level local isolation type failures, you'll need manufacturer layout schematics. But, you know, you can do a good amount of global isolation to see, you know, okay, well, you know, what's going on with, you know, electrically, can we do anything non-destructively? And then even destructive, you can actually go through and see, oh, okay, well, let's decap the die and see what's going on.
It's a fascinating area. I used to see some of the failure analysis done by one of my previous employers in the quality team, and it's interesting to see. You know, you looking at once you've decapped it, you can sort of see ESD damage and you know, or actual physical damage through overheating or too much current being drawn. So
yeah, EOS damage, electrical overstress is a very common type of failure, right?
I think that goes like about almost 98% of the failures is electrical overstress or ESD.
Yeah. So another question here for Chris. What I wanted to ask about the LFPAK was, is that that packaging then something that would a package like that belong to Nexperia, or is that something that you then license as a design to the traditional packaging manufacturers, as that other people can start to use it as a type of package for their applications too?
Now, as I mentioned, there are now several people building at least external. They look very similar. Then they're often called LFPAKs. Internally, the construction could be slightly different, but they are to all intents compatible. But it's not something we've ever chosen to patent. So it's not that we are licensing people. It's free and open for other people to build their own variants. Again, because we wanted to try and encourage adoption, so yeah, that was the approach we've taken, and I guess to the extent there are now compatible parts out there, then it was successful.
Thank you. So another question here as well for our Fusion team. Sustainability is a sort of a big buzzword at the minute. Everyone's trying to look at reuse and recycling. Is there a market, or is there room to maybe look at actually taking functional parts from boards, testing them for their performance, and then reintroducing them for integration into new products? Or is IC recycling not a thing yet?
Yeah. Now, for Fusion, we only source for new parts. So we do not handle of any recycled parts. Like I said, we are actually looking for any prior use or tampering of the parts. So we're really looking for the new parts, a factory seal, factory label. Sometimes customers look for the date code limitations. Fusion cater for that as well. But right now, QC process to ensure the parts are new, factory seal, factory label, MSL level packaging as per the data sheet. So yeah, we source only for the new parts for now.
Yeah, in terms of the future too, I mean, it's that can be tricky in terms of its reliability. So you can test parts immediately for its immediate functional test. Okay, it passes electrical tests, right at T0, but the reliability down the line, is the customer going to have, a field failure? That's something that's a lot harder to test with. And if these parts are used parts, that unfortunately introduces a lot of risk to our customers.
Okay, another question here, just looking over here for Chris. In terms of developing a new package, what sort of skills are in the team there? I'm guessing we're sort of looking at not just electronics engineers, but maybe some people involved with sort of physics background and mechanical engineering.
Yeah, absolutely. Chemical engineers, material science in all of its guys. There's quite a lot of the challenges around these new packages is the interaction between the silicon and the package itself, and how that develops over time and under stress. So yeah, so there's absolutely a full range of the engineering team, and indeed, some of Max's professionalism, if you like, in terms of the failure analysis, because not everything works first time, and you've got to try and figure out what's going on when things don't. So yeah, it's a full varied team across the organization. Then you've got, how do you test it? How do you, the manufacturing guys, how do you make it fit onto existing lines rather than to build, completely new factories to develop these things? So yeah, lots and lots of engineering goes on around getting these things to market.
Okay. Another question here for our Fusion team. if we are looking for a part, sometimes it might be necessary to actually be looking for not just a part number, but maybe some sort of manufacturing date or die revision too. Is that something that you can accommodate?
Yes, absolutely. Like I say, right, there's a lot of information that we can decode from the die code itself. Manufacturers, they do actually symbolize die revisions on the die. And the background that I came from, that I worked for 15 years, that is the die revisions on the die itself and as well as on the label. So that is actually one of our checking point, making sure that the right die is being packaged accordingly. Yes, absolutely. And of course, we always counter checks against the data sheets. The data sheets has the revisions as well. So those are the aspects that we make sure there's the latest revisions according to the date code.
Okay. And one last question then, as we wrap up our roundtable discussion, and that's for Chris. Now, we obviously, when we look in the data sheets or we compare different components, often there's, say, a standard component and then maybe a version which is automotive compliant. Does the package itself change, or is it just the process by which it's been sort of tested and the manufacturing process and the stringencies, let's say, of the specifications it needs to fulfill?
Yeah, it's a very good question. There are subtle differences in the packages themselves. Sometimes you'll find a different pound or a different solder chemical composition because it has to pass extended temperature cycling, for example. And again, it's that breakdown between the silicon and the package that becomes important. Fundamentally, they're very similar, but with subtle differences around it. Most of it is around the qualification that you have to go through and the inline extra checks and things that are necessary for automotive grade products. Great.
Well, thank you all ever so much for your time and your expertise and insights here and sharing it with our audience. It's been great having you on the show. I hope we can get all of you back on again, because I'm sure there's some spaces we can dig down to in more detail, especially around packaging and failure analysis. I think we need some die shots, I think, for the next show. That would be a good thing. So thanks very much. And
I can recommend the Nexperia MOSFET application handbook.
Yes, exactly. That's I was just saying before.
Sorry, I was just saying I can recommend the Nexperia.
Exactly, I've got my bookshelf here, and the Nexperia handbook.
There's a rogue scanner of
exactly, they're huge, great things. Absolutely fantastic, with loads of good insights and applications. And you can have it as a printed book. You don't just have to look at it as a PDF, which I love. So thank you very much for that. Okay.
Thanks,
very good.
You're welcome.
Thank you for the opportunity.
You're welcome. Thanks very much. So for many of us, component sourcing is something that we leave to purchasing. But when it goes wrong, what do? When trusted regular suppliers can't deliver, it helps to have established relationships with those who can, like Fusion. Knowing how much testing and checking that goes on in the background delivers peace of mind before committing a reel of parts to manufacturing. Then there is silicon component packaging, something few of us take little notice of. Innovation here is just as important as advancements in silicon and the manufacturing processes around it. After all, very few of us can handle bare die. So without technologies like LFPAK, we wouldn't have the compact power applications we take for granted today. Thanks so much to my experts Krishna, Ganason and Max Gates of Fusion Worldwide, and Chris Boyce of Nexperia. You've delivered us with some outstanding engineering insights. So that wraps it up for today. If you'd like more of the same, we're broadcasting 2 episodes of Engineering Insights every month in 2023. And to keep you abreast of industry trends in between, take a look at our new show, News Bites, our monthly 15-minute show. Please subscribe to Elektor TV Industry on YouTube and share our videos on whatever platforms you use. or drop by the website at elektormagazine.com/EEI to see the topics for future shows. Finally, if you'd like to join me as a guest, write me an email, drop me a tweet, or reach out to me, Stuart Cording, on LinkedIn. Thanks for joining, stay in touch, and don't forget to keep asking your engineering questions.